To discuss this topic, we are joined by a team of experts, Mitan Solanki from our business consultant team, Isaac Meyer from our partner, Arvino Digital. And we will also have the pleasure to be joined by Lesego Seokolo from Sabini Stillwater, who will give us a short interview on how he is seeing the topic of control loop monitoring and sharing his experience. Mitan, over to you.
Okay, so hello everybody. Good morning to everyone who's joining. Hope you got your coffees ready. Certainly know we have. So today, yeah, it's a really interesting topic. It's a great one to kick off 2026 with, and this series of Coffee with an Expert with. It's something that's incredibly tangible, and it's something in terms of a comprehensive solution that can really get an organization going in terms of driving profitability and just improving the efficiency of how the plant is running. So yeah, really excited to do this one today. So we're just going to do a brief introduction of who GE Vernova are for those that don't know. We're going to be talking about CLPM. You'll see that at the bottom. It's a bit of a mouthful sometimes early in the morning, but CLPM stands for Control Loop Performance Management. And obviously we'll go into this and what this actually means further into the session. Then we'll go into some use cases of where this has actually been deployed and some of the benefits that have been experienced by customers. And we're delighted to have one of our customers from Sibanye Stillwater here today, Lesotho, who will actually talk about some of his experience when it comes to CLPM being deployed across a plant that he's responsible for managing from the automation perspective. So really excited to have him here, and then we'll open up the floor to questions. So that's going to be the general flow. So just very briefly, who we are and what makes us different. So we are responsible for the Prophecy software. We are the developers of the Prophecy software, the maintainers, and really we are present in many different countries worldwide, across many different industries that you'll see there at the bottom. And our goal really is to provide a lot of really deep expertise within sort of manufacturing solutions to different industries. We either do that directly, so you can work with us directly as GE Vernova from the manufacturing division, or through one of our many partners that sort of span the entire globe, who have again a lot of deep expertise in the solutions that we offer and deployment. And pretty much quarter by quarter, we're really looking out on the market as to where really we can innovate within our solution. We can see the technology is rapidly progressing ahead, and we're keeping abreast and sometimes moving ahead of where it needs to be. So yeah, just in summary, that's where we are. And what do we do? Many of you know, but just for those that don't, we are responsible for the software that allows you to capture data right from the ground up, from where it's being generated, run that through to some of our SCADA solutions where you can act on that data immediately, receive alarms, historize that data via the historian, move that data into the cloud as well if you want, through Prophecy Smart Factory, which is where we'd have our plant application software running, with a visualization, a rapid application development tool like Prophecy Operations Hub spanning the entire portfolio. And where we're going to sort of focus in and hone in on a little bit is on the analytics side, using one of our solutions called CSense. And that's essentially where CLPM is going to be running. So that's really the engine and the solution engine that drives what we do with CLPM. And what Isaac will do is take you through some of his experience on building out some of those solutions and addressing some of those concerns that customers have. So yeah, we as GE, we really provide the software spanning all the way from level 0 on that automation layer right up through to level 3, level 4. And just in terms of challenges, so what are the typical challenges that customers come with that make us think about, okay, right, this is where we need to invoke something like CLPM. So firstly, I would say CLPM is largely applied to sort of process manufacturers, process plants. So I think things like bottling and even mining, for example. But the idea really is a customer will come to say, look, I've got a lot of bottlenecks that are appearing within my plant. How do I start to identify them a little bit earlier? I could have a human do that, or is there an automated way that could be done? The other way is, I want to sort of maximize my throughput. I want to produce more with the assets that I have on my line. How do I do that? How do I maximize the throughput? How do I maximize the yield? Is that done through sort of producing what's being produced now, but recovering more of that material back through an automated loop? Or is that to go into some more analytical detail? So these are the sort of key challenges. And sometimes when you've got an organization who are producing and making many millions and millions of euros per year, just a 1 or 2% increase in let's just say material that can be recovered can have a massive impact. That could mean the beginning of a new plant, or it could be the beginning of a new shift, a new team, or new equipment, or that can be reinvested, for example. So putting a solution like this in place is incredibly valuable when you start to look into the return that can be achieved. And others will say in terms of some challenges that they experience are, a lot of the time when these loops are not working or something's going wrong, there's usually a human that has to intervene. That human obviously can be prone to error. There could be many different variables that are going on, and they could really be overwhelmed with the number of variables that are there present in front of them with that problem. Is there a way that we could have a system that manages that and automates what's going on there, again, to eliminate that human error? So these are the typical sort of challenges which allow us really to think, okay, I think CLPM is the way to go here, to try and address this challenge. So that's why we lead into CLPM, and we've got Isaac here who will sort of take it further from here. So I'll hand over to you now, Isaac.
Thank you, Metan. Apologies, I'm having some technical issues with my camera, but thank you for the opportunity to present, and welcome to all of our audience members. You can go to the next slide, thanks. Okay, so before I dive into controller performance management, I just want to quickly pause on PID control itself. So what is PID control, or often referred to as base layer control? So in its simplest form, it's a feedback controller that tries to maintain a specific set point that's been entered by an operator and try to control a process variable to that set point. And there's a number of things that can go wrong with PID control or affect the performance of PID control. It could be tuning, it could be equipment related, etc. So controller performance management is the continuous process of monitoring and then also improving the performance of these PID controllers, because it has such a big impact on stability in the plant. So controller performance management is built on the backbone. The backbone of CLPM is Prophecy Sense. So we use Prophecy Sense to calculate various KPIs, performance KPIs of PID controllers. And then we use that data in our monitoring center to provide continuous feedback to our clients on actions that they can go and implement on site to improve the performance of these PID controllers. And this system is automation system agnostic, so it can be deployed on a Siemens or Rockwell, any automation system. Okay, thanks, Metan. You can go to the next slide. So why is controller performance management, why does it matter and why is it important? So we all know that a automation system is a very significant investment that customers make in their process. And we want to ensure that we get the most value out of the system and ensure that it's actually doing the work that it was designed for. But what we find in the industry is that between 30 to 50% of control loops on average is either running in manual or they are not performing very good in terms of how they are controlling to a specific set point. So the base layer really provides stability in the plant, and a stable plant is a sustainable plant in the long run. And this is why controller performance management forms the foundation for continuous improvement for us as Arvino in our monitoring center. Thanks, Metan. You can go to the next slide. Okay, so the base layer really has an impact on a lot of KPIs. And I think the obvious ones like recovery, throughput, and quality we all know, but it also has an impact on some of the less obvious ones like energy efficiency and equipment reliability. So if a control loop is not performing well and there's a lot of oscillation in the process, this is ultimately going to affect your energy consumption, and it's going to affect the longevity of your equipment. And this is really these value drivers. This is why it's important for people like the automation manager, the production manager, and even the maintenance manager, and where it adds value. Thank you, Metan. We can go to the next slide. Okay, so what's the risk of having poor control base layer or poor control PID controllers that's not performing well? And for us, I think there's three main KPIs that stands out. The first one is manual control. So we want to avoid the situation where operators circumvent auto control and put PID controllers in manual mode. So we all know that a computer is much more efficient in controlling to a specific set point because they can continuously make small adjustments and to maintain a specific value, where an operator might be not as effective in that because his attention is divided between a lot of things. The next one is limits exceeded. So this speaks to stability and oscillation in the process, and this could affect things like recovery and throughput a lot. So we want to ensure that the PID controllers that's running on site is properly tuned and they are very effective in maintaining that set point. And this is also going to affect things like your equipment life, etc. And then the last one is saturated control. So, and this speaks to the design constraints in your process. So if we've got control elements that's not properly sized, so oversized or undersized control element, this might affect the performance of your PID being able to control to a specific set point, or if you've got an oversized control valve, it might cause oscillation. So, and PID control or monitoring really brings this to the surface and shows this. Okay, thanks, Metan. I think we can go to the next slide. Then next, I'm just going to show a couple of use cases in terms of what we've been able to, the feedback that we've been able to provide to our clients. So the first one is in an off-gas handling system where we had a flow controller. And on the chart, you'll see before we implemented some corrective actions, there was a lot of oscillations, and this caused this controller to exceed the desired set point, or exceed the limits, as we call it. So after a bit of an investigation and data analysis, we recommended to the client to replace the damper, and also to do some maintenance on the flame sensor that we expected to be faulty. The customer went and implemented those changes, and afterwards we can see that there was a lot more stable control in the process, and this at the end of the day resulted in roughly $120,000 increase in throughput for that specific production year. We can go to the next example, Metan. So the next example I want to show you guys is what's the value of having a monitoring service associated with controller performance monitoring. So a monitoring service really speaks towards the continuous improvement or efforts that's required to maintain that performance or get that continuous improvement. So from this example, we had a client where we had a monitoring service specifically looking at PID control. And in the first wave, we could see a substantial increase in the amount of auto control they had on their base layer. Then during the middle phase or the orange area, there was a break in the service because we were working on a commercial agreement with the client. And we can see that performance kind of stagnated or reached a plateau, and it actually started to degrade towards the end of that period. And then when we took up the monitoring service again in wave 2, we can see that then that performance metrics started to increase again. So that really speaks towards the value of having a person look at the performance on a continuous basis and implementing corrective actions that's tracked on a weekly or bi-weekly basis. Thank you, Metan. Okay, so we've actually invited one of our customers to provide you guys some feedback in terms of what's the value for them. So we've got Lesego on the call. He's a senior instrumentation technician at Sibanye Stillwater. So Sibanye is a platinum producer in South Africa, and Lesego works at their smelting operation. So yeah, good morning, Lesego, and welcome to the meeting.
Good morning, everyone.
So, Lesego, I just have a couple of questions for you, and I think this, by providing your answers, I think should provide the audience with some insights into what the value for you was. So, I think my first question is, what's the typical challenges that CNI engineers struggle with when it comes to base layer control?
Okay, so yeah, we had few challenges in terms of the CNI engineers, that the improper PID tuning and taking into consideration that is not everyone that is clued up in terms of PID tuning. And then we have seen loops that are tuned too consecutively or too aggressively most of the time, and that causes a cascading instability that is also known as loop interaction. And then the other thing is the massive overshoot when the process returns to normal, and that you get most of the time when running on manual or normal auto. And then it is difficult sometimes to get visibility of overall health of the control loops, and to also proactively improve the performance. And we have encountered lots of human errors, especially on fast running loops. And then lastly, I can say we have realized also the substantial issues on the control loops, and that will only be realized only when the process control engineer complains about the PID controllers not performing well. And I can take it that if they are not at work, then basically it becomes difficult, and I can assure you that no one will monitor their performance. Thank you.
Yeah, thanks, Lesego. So how has control loop performance management, or the service that we provide to you guys, helped you overcome some of these challenges?
Yeah, we managed to overcome the poor workmanship and quality issues that we had previously. Like I've checked also on your slide when you talk about when you advise the guys to install a damper, and then you suddenly have a better control. Those are issues that we had on our side, the workmanship and also quality issues. And then on how it has helped us also on our side, we are now creating detailed and comprehensive schedules to the artisans to be able to do maintenance on the instruments. And then the good point is that we are now preventing the budget overruns. Then in terms of production and replacement of instrument in the plant, we have now a detailed maintenance schedule that is running. And then we are now getting the overall health status for our loops, and it's also driving a continuous improvement in our processes, whereby we actively operate on improved PID controllers, and that had a significant impact on our plant performance. And then with this perfect structured process that we have now.
Thanks, Lesego.
Yeah. Thank you.
Okay, and Lesego, so my last question is, since we've implemented control loop performance management, have you seen any measurable improvements in your process or in your process control performance?
Yes, we have improved. We have noticed a significant reduction in production loss. We have reduced variability and better control. And then there's also massive improvement in efficiency and throughput. We have also observed enhanced maintenance and reliability. And one of the great things is that optimized startup operation that we have seen, and then reduction in loop oscillation. And now we are able to identify its underlying mechanical issues. Then the functional and improved set point tracking. Then I can lastly say the CLM help ensure that decisions are made more effectively. We have increased percentage of automatic controls and improved our limits exceedance metric. And one more thing is that the automatic control is very pivotal because we want to ensure that the control loop is done by the automatic system and not left in the hands of the operator to make manual adjustment. And therefore, I can benchmark that our performance compared to the other operation within the organization is very good.
Thank you very much, Lesego. It's always valuable getting direct feedback from the end customer and to hear what the actual value is that they get from these systems. So yeah, thanks, Mitan. I think that concludes our feedback. Yeah, we welcome any questions from the audience side.
Yes, thank you very much. So thank you very much, Isaac and Mitan, for this presentation. It's very insightful to hear from you on control closed loop monitoring. And thank you also very much to Lesego Soekolo from Sylvania Stillwater. It's fantastic for us to hear your story directly from you on this Coffee with an Expert. So thank you very much. So we will share the recording of this session so you can replay it or share it with your colleagues. Please ask your questions in the chat. And also you can feel free to reach out to our colleagues. So to Cataldo, you can see his email on the screen. He will take care of your questions and share it with the experts that can best answer it. So let's see if we have questions right now. So first question, how long would it take to deploy CLPM on approximately 100 loops on one site? A rough timing.
Okay, Magli. So on average, I would say it takes from 2 to 3 weeks. So you normally start off with a kickoff session with the client, and then we've got a couple of workshops where we sit with the client to get the details on all of the PID controllers. So what's their control limits? We define specific shutdown rules for each controller to ensure that we get proper data from the CSense system. So we want to ensure that we've got a high quality data input. As we all know, they say garbage in, garbage out. So if we've got a proper deployment, we can get proper data out. But on average, I would say anything between 2 to 3 weeks to have a system up and running.
So there's just another question, but I think you may have covered it a little bit. So, you know, what are some of the prerequisites that are needed before someone starts?
So obviously we use CSense as our calculation or analytical engine. So we require CSense to be installed on site. And then we do data collection through an OPC DA server where we could collect real-time data via CSense, and then CSense collects that data on a 15-second resolution or interval. It temporarily stores that data in a SQL table, and then it calculates the statistics of PID controllers at the end of each shift or at the end of the day. Brilliant.
Thank you. Thanks for that. I don't see any more questions in the chat anymore, so that's fine. So that all that's left to say, I guess, is thank you for the attendance. Thank you to the audience. Thank you for your questions, and also thank you to Isaac from Harvey. Thank you so much for your insight, and Lesego as well. There's nothing more valuable than actually hearing, from a customer directly who's gone through the entire experience of understanding what challenges were there before, understanding what happens when a solution is put in place. The whole process of how people within the plant adopt that as well, how they embrace it or not. And then also at the end, really trying to see what material impacts that have on the plant as well. So really, really good. Okay, so we'll close the call now, and thank you again. See you later.